y double dashed minus 3y dashed plus 7y equals 4 cos 2x. And we've got these initial conditions here. So let's have a look at this one then. The first thing we need to do is look at the associated homogeneous equation. So here we can simply write y double dashed minus 3y dashed plus 7y equals 0. This leads us then to the auxiliary equation lambda squared minus 3 lambda plus 7 equals 0. So then if we solve that, we will get lambda equals minus b, which is 3, plus or minus square root of b squared, which is 9, minus 4 times 1 times c, which is 7, all over 2 lots of a. And a is 1, isn't it? So that's what we've got. So lambda equals then, let's write it down. It's going to be 2a, which is 2 times 1, that is. So that's 3 over 2. And this plus minus. And then we've got 9 minus 4 sevens are 28. 9 minus 28 is minus 19. So that's root 19i over 2. And we have to compare that with alpha plus minus I beta. So we can see what the alpha and beta is. This is case 3. The complex case gives. So what have we got for that then? So h is equal to a sine beta, which is 3 over 2. Beta, which is root 19 over 2. X plus b cos cosine root 19 over 2 times x, all times e to the alpha x, isn't it? That's case 3. Alpha is 3 over 2. Lots of x. So there's the line across the page. That was the homogeneous solution. Now we need to turn our attention to getting the particular integral solution, yp. So we need to try something. We've got a cosine, so the table tells us to try in that case a sine plus b cos. So let's try y equals a sine of 2x plus b cos 2x. Differentiate y dashed, because we'll need to differentiate and get y dashed and double dashed to substitute. Sine goes to cosine, and then it's something, function of function, something differentiates to 2, so the 2 comes out to be with the a, and it's 2a cos 2x. The cos goes to minus sine, and the 2 comes out again, doesn't it? So it's minus 2b sine 2x, and then we need y double dashed. Differentiate again. Cos goes to minus sine, and the 2 comes out again, so that's minus 4a sine 2x, and then the sine goes to cos, and the 2 comes out to be with the minus 2b to make minus 4b cosine 2x. There we go. So substitution then gives. So what have we got then? We've got y double dashed, which is this thing here. So minus 4a sine 2x minus 4b cosine 2x minus 3y dashed. Y dashed is 2a cosine 2x minus 2b sine 2x. That's that one. Plus 7y. So plus 7 times y, which is a sine 2x plus b cosine 2x equals 4 cos 2x. So the sines and cosines are linearly independent, so we can equate the coefficients and work out a and b. So let's do it for the sines first of all then. So here we've got minus 4a. So that's that one done. And then we've got a sine here. So expand the bracket, we'll get plus 6b. So that's the second term. And then the third term here on the left, we get plus 7a. From that term there. There's no signs on that side. So minus 4a plus 7a is 3a. So 3a plus 6b equals 0, which tells us divide by 3 all the way through. A plus 2b equals 0. There we are. That's one equation. Now let's equate the cosines. And that would be the other 3 terms, because there's 6 terms on the left, aren't there? So the cosine's minus 4b. And then the cosine here is minus 6a from that term. And then there's a cosine here, 7b, is equal to, how many cosine 2x is on the other side? 4. So what does that tell us then? 6a minus 6a minus 4b plus 7b is plus 3b is equal to 4. Okay, so we've got a plus 2b and we've got minus 6a. So I'm going to times this one by 6. I'm going to label this one as 2. And I'm going to do 1 times 6. And I'm just going to write that down. And it's going to be 6a plus 12b, isn't it? Equals 0. Label that 3. And then we've got minus 6a here plus 3b is equal to 4. And that was number 2. So they both imply, so I'm going to do 3 plus 2, of course. Add those, they'll disappear. 15b. 15b was what you get here, equals 4. So b is 4/15. Okay, good. There's lowercase b then. Now we need to get a. A is equal to minus 2b, so by 1. A equals minus 2b. I've just moved the 2b over, and that's equal to minus 2 lots of 4/15, which equals minus 8/15. So a equals minus 8/15. Let's just remind ourselves that that's what it equals there. So that's IP then, isn't it? So that's that done. So we can write down the general solution now. Y equals YH plus YP. So go back up. Let's find YH. Here it is here. Root 19/2 and 3/2 there. Yeah? So it's a sine root 19/2 plus b cos root 19/2. And it was 3/2, e to the 3/2 times x. That was the YH plus YP. And the YP, let me just get that now for a moment. YP was a sine 2x plus b cos 2x. So it's plus a, which is minus 8/15. So it's minus 8/15 sine 2x plus b, which is plus 4/15 cosine 2x. Now we need our initial condition, don't we? So I'm going to look at the page here. I've got a printout of the page to remind me of the initial conditions without scanning all the way back up. So here we've got y naught equals minus 2. So y naught equals minus 2 then. Let's put that in. When x is 0, y is minus 2. So that gives minus 2 is equal to sine naught is 0, cos naught is 1. So this is just b, isn't it? So we get b. E to the 0 is 1, so that's just b. Minus, this is 0. Sine naught is 0, so it's plus. 4/15 cos naught is 1, 4/15. So that tells us what b is then. Capital B equals minus 2 minus 4/15. That's 15, so that's minus 30/15. Take away another 4/15 is minus 34/15, isn't it? So there's capital B. There. Great. Now we need to differentiate this thing here, don't we? Which is a bit of a palaver. But because we know it's y naught, now let's get the derivative then. So differentiating, this is going to be difficult here because it's long-winded. Differentiating gives, so we get y dashed is equal to. Now the point about the initial condition, it says y dash naught. So if I get a sign, I don't even need to write it down in the product, do I? But I might not be too clever there. I'll just do this problem. So y dashed u dv dx plus v du dx. So it's u. I'm going to label that as u. save a bit of time writing it all out. This is u. Okay, and that's what I'm going to do to save space on this page. So I'm going to write down u now, but I am going to write down the dx, and that differentiates to 3 over 2 e to the 3 over 2x plus v, which is e to the 3 over 2x times du dx, and I'll put that down. The sine goes to cosine, which will be root 19 over 2 comes out, a cosine root 19 over 2x, so that's that one differentiated, plus b, and cos goes to minus sine, and the root 19 over 2 comes out, b sine root 19 over 2x, close bracket. So that's those two terms differentiated. U, and it saved me writing that, v dx plus v, and then I differentiated this. By the way, this term here will be 0, so it's not of high importance here as well. So that's that done. Now run along the row, differentiate this. The sine goes to cosine and the 2 comes out. So 2 8 is 16 over 15, cosine 2x. And then the cos goes to minus sine, and the 2 comes out again, so it's 8/15, and that's sine 2x. Again, this term here will be 0 when we put x as 0 in. So that's what we've got then for y dashed. So let's impose our initial condition, which is y naught equals minus 2. So y naught equals minus 2. What does that give then? Y dashed naught, sorry, equals minus 1. That's what I needed to write. Y dash naught equals minus 1. So when x is naught, so u when x is naught, this will be naught, and we'll just get cos naught, and we'll just get b, won't we, here for this u? Agreed? When cos naught is 1, sine naught's naught, so all of that's naught. B times 1 is just b. So we'll get y dashed is minus 1, and then this u value is capital B. 3 over 2 times e to the naught is just 3 over 2 times 1. Plus 1 times this thing here. As we said before, this is naught. Cos naught is 1. This is just root 19 over 2 times a. Close that bracket then. Cos naught is 1, so that's minus 16 over 15. And sine naught is naught. So that's what we get then. So we know a. We know b rather, minus 34 over 15. So we can get a. So this implies then that root 19 over 2a, and I'm reading from right to left, is equal to minus 1's on the other side, plus 16 over 15, plus 3, minus rather, we're nearly at the end of the problem here, minus 3 over 2 times b, and b is equal to minus 34/15. That's it. So all we did was we read from right to left, root 19 over 2 there. We then moved the 16 over 15 to be with the minus 1 and make it plus. And this was minus 3 over 2b, and b was minus 34/15. So we're dealing in 15ths, aren't we? That goes into that 17. So minus 15/15 is the first term, plus 16. And then minus 3 times minus 17 is plus 51 over 15. 16 take 15 is 1, so we've got 52 over 15. 3 goes into 15. 3, 8, no it doesn't, so we're okay, 52 over 15. So now we just find out a then. A equals, move the 2 up, so we get 104 over 15 root 19, which I'm going to leave as it is, like so. Okay, so root 19 came down, the 2 came out to be with the 52. That's it, that's A. So that's the end of the problem then, really. I'm not going to write down the long-winded solution. Here's a solution here. So the value of A, we determined from here was 104 over 15 root 19. We put it in there. And the value of B is minus 34 over 15.